Everyone, my name is Darcy Gray.
I'm Amia Kalra.
I'm Amy Kennedy.
And as was mentioned, we've been working with Asheville's Urban Forestry Commission for the past 9 weeks to put together this project about tree cover and urban heat islands in Asheville. So today we're going to walk you through some of our results. So the urban heat island effect is a phenomenon where a city experiences average temperatures that are higher than its surrounding areas. And this is due to things like an increase in impervious surfaces, like parking lots and buildings, and usually less tree cover. So we want to emphasize that the urban heat island effect is a phenomenon that exists separately from climate change. So it's not caused by climate change or by greenhouse gas emissions, but rather by changes in land use and land cover. However, it can be exacerbated by climate change, and as global temperatures are rising, we'd expect to see the extremes that are experienced in a city being even higher. When we wanted to look at the urban heat island effect in Asheville, we didn't have thermometers to go around and take the temperature on every single street, so we used the next best thing, which was satellite imagery. The data we'll present is based off of NASA satellite-derived land surface temperature, which is a little bit different from the air surface temperature you might be used to seeing in weather reports and on your weather app. Land surface temperature measures the actual skin temperature of the Earth, and not the air above it. So that means that in our medians for, say, a parking lot might be really high, probably higher than you'd expect. And then as anyone who has walked barefoot across maybe a grassy field into a parking lot can attest to, there can be really large variations in land surface temperature on a really small scale. So that doesn't necessarily mean that you'd experience that much temperature shift in the air surface temperature. The two are related, air temperature and land surface temperature, but we're just using that measure of temperature. So this map on the left shows median daytime temperatures for the warm months, so May through September, for Asheville from 1984 to 1986. And to give you a little context, can you see the laser there? Hold on. Okay, so this area in the middle is the downtown area. This is South Asheville and the airport. And over here is where the outlet mall is. This is the northeast area. So you can already see what I'm starting to talk about, where there's these large changes in a small area. Even within the city, you can have the lows, which here are represented in blue, down in like the 30s or the 50s and 60s, but the highs are going to be up in the 90s. And this map is the same data for 2017 through 2019. So again, these are looking at land surface temperature, and you can start to see what areas of town are really kind of heating up. Down by the airport, where there's been a lot of development, the map is turning more red, and the area around downtown that's red is expanding. And these are changes that you would see even in a stable climate. So these are caused by the way that we're using the surface of the land. So what we wanted to know was, how does tree cover specifically relate to this? And how does Asheville's recent loss of tree cover play into this issue?
So we know that trees provide cooling effects that can mitigate heat, as Shirley mentioned in her presentation. So as Darcy said, we wanted to see how trees and land surface temperature in Asheville correlated. Later on, we're going to be using population data, so we decided to do the bulk of our analyses using census block group data for this. So we made a scatter plot with these two variables, with the high-resolution tree data that Davie Resource Group gave us and the satellite-derived land surface temperature. So you can see in the top left of the scatter plot, the block group that's associated with the lowest tree cover, around 10%, is associated with the highest temperatures in all of the city. And then on the bottom right, those block groups that have much higher tree cover have lower temperatures. So you can see the line in between indicates a strong correlation between these two variables.
So once we know that relation existed, the next question that came up was, how does that relate to people who actually live in Asheville? How does it affect them? And to answer that question, we made a heat vulnerability index. So there have been lots of other vulnerability indices that have been made by other studies, and the typically accepted definition of what vulnerability is by them is that it's comprised of exposure, ability to adapt, and sensitivity. So for our project, we used land surface temperature, like Darcy was talking about. We used tree cover from Davy Resource Group, and we used age and poverty level, and we'll talk about all of those in the next few slides in more detail.
So the first component of our index was taking that land surface temperature from before and finding one value for each of the census block groups in Asheville. So the map you're looking at is the 85 block groups in Asheville, so those are a little bit smaller than the tracts that we just saw in the other presentation. And the reddest ones are the most heat exposed, so they have the highest temperatures, and the pale pink color is the lowest temperatures. And you're gonna see a similar pattern because this is based on the same data as before, so the downtown area is quite hot, and then up in the northeast, you've got cooler temperatures.
Then we took the tree data by block group from Davy and we put that into the index. And the lighter colors here represent lower tree cover in a block group, and the darker colors represent more tree cover. So you can see in the northeast area of the city, it's a very wooded area, and in spots like downtown in the center of the map, or at the airport on the bottom, it's not very wooded, it's less tree cover, which makes sense because it's more developed in those areas.
So the third part of our index was the socioeconomic factors. For us, that meant age and poverty. We put age in there because as you get older, you're more likely to experience health problems that can be caused or made worse by heat. And poverty's in there as well because if you have a lower income, it's going to be a lot harder for you to get access to resources that can help you handle extreme heat. So this map, similar to the last two, is the census block groups in Asheville. The darker blue means that there's more people living in that census block group who are above the age of 65 or who are living below the poverty level. And the lightest blue is the opposite of that. And this map is different from the last two because it doesn't quite follow the same pattern, so you can't look at this one and see an immediate resemblance of the last two maps. So to get our overall heat vulnerability index, we took all three of those variables. So we have land surface temperature, we have tree cover, and we have socioeconomic factors, and we added them all together to get this final overall heat vulnerability map. So this map is the combination of all three of those factors. So what you're looking at with this map is all the census block groups in Asheville. The darker brown means it's the most vulnerable, and the lightest yellow means it's the least vulnerable. So just to give you all some context as to what part of town you're all looking at, this red circle that just popped out over the dark brown block group is AB Tech, where we are right now. This circle and the dark brown bit in the middle is downtown. This one is the outlet mall. Here's the airport. And then up north we have UNCA. So this map is showing what parts of Asheville are most vulnerable to extreme heat from urban heat islands. And that kind of information, since it's a combination of those three factors, you can kind of see that some block groups might be marked as vulnerable for different reasons. So one of the block groups might have a really high social vulnerability, but also a lot of tree cover. And one of the block groups might have really high temperatures, but also low social vulnerability. So you can kind of see that there's different reasons for why different block groups are marked as vulnerable, and organizations that want to use this data can then use it to see what parts of town they want to focus their work on and why.
Okay. So as many of you probably know, Asheville is a growing city. Since 2008, the population has grown 10%, but at the same time, we've lost over 6% of tree cover. So with a growing population and therefore a greater demand for buildings and other impervious surfaces, which contribute to the urban heat island, the presence of trees and their cooling effects is especially crucial to offset that heat. And we want to clarify again that climate change is its own global phenomenon, and the results of the study we did are hyper-localized and focus on the microclimate of Asheville directly related to urban heat islands. However, while we would see these land surface temperatures rising even in a stable climate, climate change is going to make the effects of the urban heat island more drastic. And this research has also opened the door to a lot of really great questions and project ideas that aren't necessarily within our scope because our project is ending, but would be good to be investigated in the future by others. So we would like to thank you for your time and for being here today. And if you have questions regarding our work, you can reach the contact info up there about our program. And we want to thank our fellow, Andrew Shannon, and our science advisor, Scott Stevens, and our partners at the Urban Forestry Commission, who we will be giving our results and data to after this. So you can also contact them if you have any questions. And thank you.